Okay, so we talked about proportional relationships, and we had our equation that we generally used, which was y equals kx. That's supposed to be a k. Y equals kx. And then I mentioned several times that they also have this variable m that they use sometimes, and actually use a lot more. And we talked about how k is equal to y over x, and that's not always true with m, which is, I think, why they do the different letters. But now we're going to talk about rate of change and slope. And when we talk about slope, we're always going to use m. And I'll show you this in a second. But so let's just start with an equation. So the rate of change is the ratio of the amount of change in the dependent variable or output to the amount of change in the independent variable or input. Right? Yeah, that makes lots of sense. So what it's saying is that the rate of change is how much does our output, our y, how much does that change based off of our input x? And that's what we call slope or constant proportionality. Okay, slope, again, is slightly different, and I'll show you that. So let's just take this example problem. Eve keeps a record of the number of lawns she has mowed and how money that she has earned. Makes sense. We want to keep track of how much money we're making for how much work we're doing. Yeah, I started so well. So we're gonna, oh, that's not gonna work. Okay, so we're gonna have this table. Hey, I think that's worse than usual. I started it really, really nicely. It was a really nice table when I started. Okay, so we have this table, and we have our x, which is our number of lawns, right? Because that's what we can control. We can change how many lawns we mow. We can't change how much money we have without changing how many lawns we mow. So x is our independent variable. That's the one that can change. And then y can change as well, but it's dependent on how much x changes. So we'll just say that mowed one lawn on this day and made $15. Mowed 3 lawns on this day and made $45. Mowed 6 lawns, must be getting faster at the lawn mowing thing, and earned $90. And then on day 4, mowed 8 lawns, made $120. That's pretty good. Okay, so this is the table. This is how much she makes, and we can figure out how many lawns. And because it's a proportional relationship, right, if she doesn't mow any lawns, then she doesn't make any money. And so it starts at 0, 0. So if we had our graph, it would start right here, 0, 0. Okay, and then as we are graphing it, if she mows 1 lawn, it goes up to $15. If she mows 3 lawns, it goes up to $45. And we can make this line, and you could follow this graph, and any number of lawns would have some amount of money. So this is the dollars, and this is the lawns. Okay, that's not really necessary, but just so you can kind of picture it, as the number of lawns goes higher, the amount of money goes higher, proportionally in a straight line. But it starts at 0, 0. So because it starts at 0, 0, really what we can say is, we can say, well, our k is just our y over our x, which is 15 over 1. And that's true. But what they want us to do for this one is find the slope. Okay, we want to find the slope. And the slope, and this is where it's different, the slope is what we call the change in y over the change in x. And to be able to find the slope, we have to have 2 points. And so for this one, and it doesn't matter which 2 points, I'm going to take the 90 and the 45. Okay, these are both of my y values, and I have to take the corresponding x's. So change in y over change of x is the same thing as y2 minus y1 over x2 minus x1. Okay, this is all slope. So my y2, let's say that this is my, I'm going to call this point 2 and this point 1. So y2 would be 90, y1 would be 45, so I'm going to do 90 minus 45. Divide that by my x2, which has to go with my y2, so that's 6, minus my x1, which has to go with my y1, so 3. Well, that's going to give me 45. 90 minus 45 is 45, and 6 minus 3 is 3. So 45 over 3 is 15, which was the same as our k. The times that this is going to be different, so this will always work as long as it starts at the origin. But sometimes it'll be something like Eve, she was the lawnmower person. She had some amount of money in savings already, and she wants to know as she mows her lawns how much money she has. And so her line's going to be more like this, and that's going to change how this comes out. Okay, so your slope could be the same, but it's gonna change the numbers in the table, and it's going to change your equation. So that's why we really would like you to use slope more than k, the constant of proportionality. K was like this cheap trick that we could use for a little while, but it basically is going to go away, and we're just going to use slope. Okay? So what would our final equation be? We have y equals m times x instead of k, because we found slope, not the constant of proportionality, even though for this particular problem they're the same. They're not always going to be. And so because we found our slope to be 15, our equation would be y equals 15x. Okay? And you could do that with any 2 points, and it would still come out to be y equals 15x because this is linear. In this case, it's also proportional because it starts at 0. Hopefully this is helpful, and you have a good idea of how slope, rate of change, same thing, and the constant proportionality all relate.